URL, unfortunately. Got it. Once it happens, I'll give you the link and everyone can spread it on Twitter. Here we are, live. So I'm going to put this in new YouTube URL. I'm putting that in Clubhouse. And now I'm going to put it in Zoom. And if Eli or somebody can post it on Twitter, I will do it too, actually. Welcome, everyone, to Clubhouse. I'm your host, Dan Miller. And today we have a kind of a different kind of thing. We got our co-mod, Stacey Randecker, is going to give us a report on her trip to Santa Barbara to listen to climate scientist Michael Mann. And I believe you also listened to Albert Bates as well. Is that right?
I did. And you're not going to believe this. Well, I'll show you. I met with one of my urbanist friends. Keep State Street car free. He gave me his poster. And guess who I had breakfast with?
Breakfast with Albert or Michael? Wait. I'm not watching right now because I'm trying to get to Twitter.
Oh.
What does that say? Oh, Elliot Jacobson.
Yes.
Our previous guest.
Yes, it was quite the weekend here in Santa Barbara.
Wow. So give me 1 second as I post. Here we go. Let me post this one. New URL for our live climate chat. Okay, so I posted it on Twitter. So before we get to what Stacy has been doing, I want to tell you we have this is like an open discussion program today. So we'll be listening to what Stacy has to say, and then we'll all can chime in on that and talk about other climate news. But we have some great upcoming programs starting next week. Next week, we have David Fenton, who maybe our in terms of number of times, I think maybe our number one guest. Mm-hmm. David is an expert in communications. He started the largest PR firm for social causes. He's worked with Nelson Mandela and Yoko Ono, and boy, an incredible story actually there. And we're going to talk about climate communications and what we can do to be more effective at it. And that's on that's on March 3rd, next Sunday. The following Sunday, March 10th, we have Dr. Renee Van Westen, who wrote a paper on AMOC collapse. So we're going to be following up on the other interviews we've done on AMOC. And her paper focuses on both the probability of AMOC collapse as well as what happens when the AMOC collapses. So that's going to be super interesting. And then the following Sunday, March 17th, we have another return guest. He was on Clubhouse before. This will be his first time on YouTube. Professor Doug McMartin from Cornell University, who is a researcher on SRM, sunlight reflection methods, solar radiation management, solar geoengineering. And we'll talk about both, the ability to be able to do it and the effectiveness of doing that. As you know from discussions here, we think that that's going to be a necessary step, a necessary tool in the toolbox for fighting climate change. And then also, while we don't have a particular date scheduled yet, it'll be fairly soon. Another return guest that was on Clubhouse, maybe one of our most popular guests ever, climate scientist Kevin Anderson has agreed to do another interview, this time on YouTube. However, it won't be at our normal Sunday morning time, but it will be at probably a weekday morning. And so we'll post more about that when we fix the date. He did write to me this morning, said he's happy to do it, and will get back to me soon with what time works for him. So with that out of the way, please, first of all, please subscribe to the channel so you get alerts of these upcoming shows, and hit the like button as well so that more people get access to this. Yeah, smash that like button. So with that, I'm going to first ask, Stacy, just to give us a report on your activities over the weekend, what you did, what you saw, and then maybe first an overview, and then we'll get into first Michael Mann's talk and what you heard from him, and we can talk about some of the issues. You said it raised more questions than it answered, maybe, and then the other things and the other folks you spoke to. All right, turn it over to you, Stacy. Go ahead.
Okay, so I think any one of the things on their own wouldn't have been enough, but when you have Michael Mann speaking on the campus that my daughter attends 2 weeks after she proclaimed her outrage at what are we doing around the climate, even though mom has been upstairs doing this every Sunday morning for like 3 years. And then Albert being honored, who typically resides in Tennessee or at some eco village around the planet, and he happened to be here. It was the universe kind of said go, and so I did. And I took the train because it's a bus, because we don't do transportation properly in California, and I got down here to see Michael Mann on Friday night at UCSB. And it was, I was surprised that, and also I had tweeted to Elliot Jacobson about, is he going to go? Because I thought, well, I know he's down here. That would be, and no, he's a very early to bed, early to rise person. So he said that the 7:30 start time was past his bedtime. So he did not attend. But that was my big, oh my goodness, moment is when both of them followed me within an hour of each other. So that juxtaposition was quite, it made me smile. Anyway, Elliot asked, why do you think that Mann followed you? And I said, well, because I tweeted about the event. And he's like, well, surely other people were. And I said, no, I mean, this is real. But when I walked in that room, I brought down the average age considerably, even though it's on a university campus. But it's a Friday night. And the kids are not, they are concerned about climate, but apparently not that much. There were some ushers that were obviously UC students. I said, I think I saw like 2 12 to 13-year-olds that were drugged by their parents there. But the rest of the audience was a lot older than I am. At least that's.
And this was a university sponsored?
Yeah, event? It was right on campus. In fact, my whole transportation thing, I had been using the place I was staying that night. It was in Santa Barbara. And there's a wonderful bike share program that I could use, but it should be the University of Goleta, not the University of Santa Barbara. There's quite a distance in between the two. I don't recommend biking it. You can, if you have a bike, put it on their transit. But I didn't bother bringing my bike down. I did want to meet my daughter. I wanted her to go to both events with me, but she declined because it is the weekend and she's a freshman and doing her thing. And she said, well, you can, and I wanted to give her baked goods that I brought down for her. And she said, okay, well, you can use my bike. So I took transit to the campus, and then I borrowed her bike, and I just left it at the place locked up because she has all her classes right there because she's a bio major, and she was in that Science Central where he spoke. So yes, university event. but not a lot of university students that I saw, a lot of an older crowd. And I think that was one of the things that I realized, the conversations that we have here, anyone who shows up has a baseline understanding of climate and what's happening well above the general audience that was at this talk. And so a lot of what he does is it's very light. It's, it doesn't get into as many details as we might hear on climate chat.
Makes sense. Yeah.
And so, and also what I deemed as gross oversimplifications. Shout outs to doomers and techno bros. It's almost a characterization because there's so he was saying that the techno bros think that you can just use carbon capture and do nothing else and it'll all be fine. And for me, I don't know anyone who, credible, who's saying that anything that we do in terms of air capture is in conjunction or as a method of last resort. Only like the greedy oil barons would recommend doing that and that alone, and to continue on as normal. And then the same thing with doomers. He was saying that they believe that the world's going to end in 10 years. And I mean, yeah, I know that there's a niche group of people out there that think that, but that's not what the data shows today. And so no one that I would, consider a real person who's concerned about the climate and looking at climate data says that. So, but it's a lot easier to sort of address those things and move on to the next topic for that kind of audience. So, I mean, I don't know whether to give him the benefit of the doubt because of the type of people that he's speaking to, or if that is what he really believes, and that there is no middle ground in these sorts of people and discussions. So.
Okay. And did he give warnings and recommendations what to do?
We need to cut our fossil fuel consumption, and that he believes anything that's being said about methane is not about feedbacks. It's not that we've crossed tipping points, and it's all the being released from the permafrost and the ice that we are losing. He believes that the signature of the methane shows that it is due to extraction, and that if we simply stopped extracting, that will be sufficient. And while I would agree that, yeah, if we stop extracting and if we, capped essentially every well that there is, that would go a long way to solving our methane issues. But I think it's also very simplistic to say that that it isn't happening in the Arctic, that we don't have these sort of feedbacks that are happening and will be cascading for years to come.
So to be clear, he's saying that he thinks most of the methane is coming from fossil fuel extraction. Mm-hmm. And I assume he didn't say none of it's coming from feedback, but he's just implying that not much is coming from permafrost melt and things like that.
Right. That the vast majority of what we have and will continue to have is extraction based. And I mean, we've talked with Bob Haworth about the emissions that happen in the leakage. I mean, it's a very messy process. The whole notion that we have this well-oiled machine, so to speak, of how we get it out of the ground, how we refine it, how we get it to where it needs to be is comical at best. And hydrogen is just essentially a carbon copy of that. It's just shiny on the outside.
Well, one problem, though, I mean, let's assume he's right. And by the way, Bob Haworth also thought that most of it was coming from fossil fuel extraction, especially the fracking boom in the United States that coincided with the increase in methane in the atmosphere. And that could be true, but it's also very possible that if we do everything we can to reduce those emissions, by the time we do that, that other processes, such as permafrost melt, are kicking in, and basically you're crossing your fingers and hoping for the best, as opposed to assuming that you should hope for the best and plan for the worst. And so,
yeah,
but keep going.
That's in speaking with Elliot this morning, that's the thing that I reminded him of what you're always saying, when you're faced with options of possible outcomes and this is what's on the line, our planet, the Holocene era, 10 to 12,000 years of fairly stable climate, and we're watching it pass by us. We're entering a new era, and that you wouldn't do everything in your power to stop that, to halt it, no matter what it was coming from, it's cuckoo. Like, I just don't know how.
Well, let me ask you a more general question. Do you think that the general people that were, because you know a lot more about the general audience here. Do you think the general audience that came to hear Michael Mann came out of that talk more concerned than they were before, number one, and more inclined to act on the climate? Whether that would, and did he give them particular action points to pursue?
I'm going to say no and no. To me, it felt, and I wish there was an exit survey. I wish there was a way to know, because I'm measuring it on my, through my transportation lens of I believe I was the only person at the bus stop to go back into Santa Barbara. I think everyone else was getting in their cars. Now they may have been electric, but I know no one was getting on their bike to leave that. So I don't know how, and would they go and turn over a new leaf the next day? Who knows? Maybe. But I think the thing that is troubling about these types of talks is I feel like it's what people who are concerned do to assuage their guilt. They go to a talk like this and they feel like they've done their part, that they have ticked off their climate action box for the week. Maybe they bought the book. Maybe they'll read it. Maybe they will make a change, but that everything is ever so slight, that it amounts to one less cookie instead of putting down the tub of ice cream and the whole birthday cake,
But anyone has limited ability to change people's behavior, as we talk about so much. We'll talk about next week with David Benton. So I'm really asking something different. Did someone who listens to his talk, would they walk out with a more heightened sense of urgency? Like, obviously they were concerned about climate to begin with, because that's why they went to the talk, or maybe they're at least curious. I mean, the thing about Michael, when I listen to him, first of all, he says, look, what we do know already is enough to be worried. We don't have to add to it, which is when he talks about doomers and things like that. But when I hear him, he also, to me, he's kind of saying, but don't worry, if we do cut our emissions by 2050, then things will be okay, which I don't agree with. But even the messaging to me is one of a calming, rather than one of, oh my God, I got to get out of out of this auditorium quickly and start organizing the vote or whatever it might be.
Yeah.
So what was your feeling then? Sort of that high level urgency message.
There, I didn't have that at all. And now, in hindsight, is it because I have an idea of what his general message is? And so, unless someone is sounding alarm, I mean, I need Greta Thunberg there, who is shouting at people to change and do things differently, and how dare they, and embarrass them. That is what makes me feel like it is. And she's been doing this for years, or I don't even think she does it anymore. She already did it so many times, just absolutely embarrassing the people in power who have the ability to make the change, about how dire this time is. She's over there and he's over here. They're just, no, I didn't get that impression at all.
Okay. And did he talk about upcoming tipping points or escalating extreme weather that we are already seeing? Did he? So what were the major points of his talk? Maybe put it the other way, rather than asking what he did. He talk about this and that. What did he talk about?
So I froze. Sorry. I arrived fashionably late because I was doing the handoff with my daughter, and when I walked in, he was playing it's a Police song, and it's about the dinosaur, and he was explaining how they wrote this after Carl Sagan's nuclear winter speech or paper. I don't know. I was clueless and in middle school at the time, elementary even, I don't know. And but it actually, the words of the song, it was describing about what it would be like if we got to that point, but he feels that it actually is quite relevant today about how things might be with the climate. So I guess that's the most cautionary thing I felt coming out of it, is, that things are changing, but it was, and maybe I missed the key part at the beginning that might have been more gripping, but it felt very easy, like, hey, we can do this, as opposed to the call to action that I'm always seeking.
So there's no recording of it that's available?
I'm not sure. They definitely were recording it, but when I looked online, nothing seemed to be available right now. So
how about call to action? Did he, at the end of the speech, did he give a call to action to the audience? Whatever that might have been.
I'm going to say no, because I have no idea what it was. If he did say one.
Not a clear one.
No. I don't think anyone had any. I guess that's the thing I struggle with, is when I leave something like that, I would want to know, here are the clear things we should be doing. Here's what you can do as a person. Here's what you should be encouraging others to do. Here is, what you should, writing your electeds, this is how we can make this change. And I was tweeting it, so I cannot say that I had faithful attention to every single word he said, but at the same time, there's nothing that bubbled up with enough intensity to make me feel like people were walking out of there and going to do something about it beyond be feeling bad about their trip to Europe.
Okay.
He did later retweet your tweet about the 2024 election, right? That it we can't reelect the guy who pulled us out of the Paris Accords.
Yeah. Well, that was he just said that elections were important and that we had to do the right. That was my wording. About the guy who pulled us out of Paris. But
at least he's publicly
I didn't
on board
see his,
with that.
And I didn't see his retweet because he blocked me. because I would tweet about what Jim Hansen said, and he doesn't like that, and also, I think I made a comment like, what did Michael Mann mean about 1.5 degrees in 2050? How can that possibly be? He didn't like that at all.
Oh, that is one thing.
That.
And it's hard because I'm so used to going to discussions where the audience gets to ask questions in real time. That's like I'm the person, but there was none of that. You had to submit questions prior anyway. But he said about 1.5, because I'm sitting there knowing, Leon Simons faithfully putting out where we are in terms of this trajectory and this and how things are off the charts, and that at the conclusion of January, we have passed 12 months straight of 1.5 degrees warming. And he did the goal line pushing thing that I guess started happening in the fall when people suspected that we were going to cross this threshold. That it's not in a day, a month, a year. It's the trend line. When the trend line is above 1.5, and I'm like, oh, I don't recall that being the rules when we were first talking about this. Not that I recall.
No, that is correct. That it is the trend line, which is sort of, think of it as the average temperature, because when there's an El Nino, it's a little warmer than normal. Okay. When there's a La Nina, it's a little cooler. And so what we mean by crossing 1.5 is sort of when, think of it this way, half the time it's above 1.5, half the time it's below 1.5, with the variations, with the noise, the year-to-year noise. But the problem is we just hit 1.5. That was half a year of not particularly warm. This year, if it's above 1.5, that means when it does cool, it'll be a little bit below 1.5. And that means this is the trend, or very close to the trend. Certainly within this decade, we'll be over it. And because also the other part of it, which Jim Hansen likes to emphasize, is that the Earth energy imbalance, the amount of energy coming into the Earth is more than the energy leaving the Earth. And that means the Earth is going to warm up. That's what that means. So wherever you are now, you can argue a little bit if you want about exactly where you are. There is no doubt that the Earth is getting warmer because more energy is coming in than is going out. And the number is a huge, huge number. It's on the order of equivalent of 1 million Hiroshima atomic bombs going off every single day. That's how much extra energy is being absorbed by the Earth and is leaving the Earth. If you keep doing that every single day, things are going to get warmer. And so anyway, that's just a little point to be made on the 1.5 issue. I still don't understand how he can argue, which he did fairly recently, that if we get to zero emissions by 2050, which doubtful we will, but let's assume we do, he said then we can stay within 1.5, and just see how that's even theoretically possible. I don't even understand it.
Dip below 1.5 again?
Go ahead. Yeah,
do you think we will dip below 1.5 again?
Oh, very possibly. When the next La Nina happens.
Well,
We might
and
hit 1 point,
possibly,
but the thing is, if we hit 1.4, that means we're at, with a La Nina, that means we're at 1.5 trend.
I
That's
thus
what that
I don't
means.
think I don't think that I don't think that we're going to credibly see it as this is our existence anymore. I mean, we aren't changing enough otherwise to make that happen.
well, this is one thing that we
Well,
need to
that's also
mention
true.
locally. We expect, actually, or at least one of the forecasting agencies has predicted La Nina to come back August, September. So that's a little bit of mercy for some places, because it's El Nino that has been driving the extremes being quite as high as they are. But we're not seeing rebounds in sea surface temperature or ice extent yet, and those are very, very worrying. It appears that we're in a new regime with regard to those and other things, and it would take many years of below average to be able to say, well, no, we actually weren't in a new climate regime in 2023, 2024.
Yeah, I think those days are kind of gone. But although the one I mean, we can always come back. I don't know how much more there is to say until he shows up in the Bay Area, which he said he would let me know, that he does get there quite often. So I would look forward to that. And but in Albert's talk, biochar, and this I want to see the math because it sounds like it could solve a lot. Oh, Dan? Oh, is it just me?
I still hear you.
You hear Dan?
No, I hear you. I don't hear Dan.
Oh, Dan, here. Oh, wait a minute.
I was on mute.
Okay, all right. I'm like, I can hear him.
I was saying, let's listen to Robin,
Okay.
who
yeah, thanks, Dan.
Go ahead.
If you look at temperature records from 1972, the world's been warming at about 0.19 degrees centigrade per decade. Hansen's view is it's now speeded up to 0.27 C per decade. So we will breach 1.5 before 2030, and we'll breach 2 degrees centigrade by 2050. So this is partly based on the fact that he uses a different climate sensitivity from IPCC. IPCC use a climate sensitivity of 0.75 C per watt meter squared, whereas Hansen reckons it's more like 1.2. That's based on paleoclimate data from the last 2 ice ages. So we haven't got any chance of staying within 1.5 whatsoever. The best we can hope for is to overshoot and then try and claw it back using carbon negative technologies that don't yet exist, or certainly not at anything like the scale needed. So my view is the IPCC should abandon 1.5 and clearly state that we cannot achieve this. We have to go beyond and then try and get back.
Okay. Well, a few points on that. Hansen also thinks that because of the drop in aerosols recently, mostly from shipping regulations that lowered sulfur and ships' fuel, that the actual increase in temperature is now about 0.49, or a half a degree a decade, which is insane, by the way, how much that is. Which means we'll be at 2 degrees in the early 2030s if it kept going at that rate. And maybe it won't, because maybe we'll stop lowering our aerosol emissions as much as we are. And of course, we could also step in and increase the reflectivity of the Earth by putting sulfur in the stratosphere, by brightening marine clouds, and doing, there's other techniques we can use. We're going to be talking about that in a couple of weeks with Doug McMartin from Cornell. And so anyway, so Hansen is saying actually in the short run, the acceleration of warming is way more than was previously. 0.18 is, I think, what I remember, and up to 50% to 50% more than that. But now it's actually even more right now. So yeah, we're blowing through 1.5. That's not really a question. We're probably going to blow through 2 at a far earlier time than was expected, unless Hansen is way off. We're going to find out in the next few years. We're going to see what this year brings. There's been some news that the temperatures haven't continued to go up as crazily as they did last year. They're kind of hovering about where they were, which is still crazily high, by the way. And so we'll see what this year brings, whether the El Nino fades quickly. And if it does, this year might not be 1.7, but it still could be 1.5 or 1.6, which is still very, very high. So yes, there's a lot there. And we had Jim Hansen on as a guest. You could listen to that by going to our Climate Chat YouTube homepage and finding the Jim Hansen interview. He was disinvited to the COP meeting because his views do counter what the IPCC says. You mentioned climate sensitivity. It's also measured as how much would the world warm in the quote short run, not really short,
that's
for
right.
a doubling of CO2. And the IPCC generally uses 3 degrees Celsius, and Jim Hansen said it's 4.8, which is obviously very significantly higher. And also said that the cooling from aerosols is much more than we assume. There are some satellites, I think, being launched this year that might help measure aerosols, which might give us a handle on what's going on there. But the drop in reflectivity because of the ship's emissions seem to have a big impact on warming, far more than the IPCC would attribute to shipping. And so there is a disagreement, and probably somebody's wrong, and we're probably going to find out soon. I usually bet my money with Jim Hansen. I mean, there's always a chance he's
Me
wrong,
too.
but yeah. Go ahead, Robin.
So the aerosol thing is very interesting. I mean, Hansen goes back to the sort of mid Holocene and says that there has been a rise in the level of GHGs as identified by ice cores from Antarctica, and that methane and CO2 have increased since the mid Holocene, but there's been no corresponding increase in temperature up until the start of the Industrial Revolution. And he attributes that to human activities like cooking and other human activities that release aerosols into the atmosphere. So he thinks that the warming that should have occurred since our Neolithic ancestors started forming civilizations has been completely disguised by aerosols. And of course, it's not just the aerosols. He thinks it's the effect of the aerosols on cloud formation that amplifies the aerosol effect.
Absolutely.
But none of the scientists will accept that aerosols per se could do it. It has to be via cloud formation that the cooling happens. So right. When the IPCC talk about net zero, they're only talking about CO2 or sometimes greenhouse gases, but they never include aerosols. And aerosols, because we're diminishing the amount of aerosol in the atmosphere, that is a new forcing, which the...
Well, that's not true. I would disagree with you on that. The idea is when we get to net zero emissions, that includes aerosols from the fossil fuel emissions. But what happens is the reason that scientists like Michael Mann say that temperatures will stabilize after we stop emissions is because while there is, quote, warming in the pipeline, I mentioned the Earth energy imbalance is taking in more energy than going out. That's countered by the fact that the oceans will continue to take up CO2 at the same rate they're doing it today, even after we stop emissions. In other words, the oceans don't know how much emissions we put in the atmosphere every year. It only knows what the total is. Yeah. And the total is enormous, by the way. It's 1 trillion tons more. and we only put up 50 billion tons more every year. So it's going by that trillion ton differential. That will still be there after we go to zero emissions. So the oceans will keep taking up CO2. That will help cool the planet, and that will counter the Earth energy imbalance, we hope. If Hansen's right and it's really 4.8 degrees climate sensitivity instead of 3, maybe it doesn't counter it exactly, and the Earth will continue to warm for a while. That's number one. Then you get the aerosols. Assuming they go away, that will be a lot of warming. But that is supposed to be countered by the fact that short-term greenhouse gases like methane only last in the atmosphere for 10 to 20 years. So once you stop emitting those to zero, in 10 to 20 years, they're gone. And methane is what, like 2/3 the warming of CO2. By the way, what's interesting about methane being 2/3 the warming of CO2, we've added 140 parts per million of CO2 to the atmosphere. We've increased it by 50%. That's, think of 140 parts per million to the atmosphere.
Yeah.
We've added 1.2 parts per million of methane to the atmosphere.
Yeah.
1.2 versus 140, and it's 2/3 the warming of CO2.
You've got to start saying
methane is very effective
145.
at warming the Earth.
Wait a minute,
Go ahead,
Dan. You're saying it's 2/3 the warming. I think you mean it's 2/3 of total warming.
No, if you take how much warming CO2 is, you say that's that much. Methane's about that much. But then you also have aerosols cooling. Those two would add up to more than 2 degrees. But then you take off the 0.5 degree for methane and you get down to roughly 1.5 degrees. There's some other nitrous oxide and other things too. But basically it's CO2, methane. Those are the two biggest warmer components, and aerosols are the biggest cooling component.
But I thought
methane, gotta add it all together.
I thought methane was much more effective at trapping heat. It's just it doesn't last as long. Isn't it 6 times more potent than CO2?
It's 120 times.
120 times more potent.
While it's in the atmosphere.
But we lose it in 10 to 20
But
years.
it goes away.
Okay.
Again, let me say, we've only added 1.2 parts per million of methane, and we've added 140 parts per million. I'm sorry, I have echo, so I'm going to turn this down a little bit. 140 parts per million of CO2. Okay. So, in other words, we added a tremendous amount of CO2, and it has a certain amount of warming. We added a tiny, tiny, tiny bit of methane, and it still has 2/3 the warming of CO2.
Okay.
Now, if we stop doing everything, the CO2 would stay there because it stays in the atmosphere for hundreds of thousands of years, and the methane warming would reduce. There's still natural methane. It wouldn't go to zero. Again, it's 1.9 parts per million right now, and pre-industrial used to be about 0.7. And there is talk, by the way, growing rice gives off methane, and humans have been growing rice for thousands of years. So there's sort of talk that the reason we had a stable climate is because we had this little bit of methane from rice that instead of the Earth cooling going to the next ice age, it kind of stayed this way. And then, interesting, when we started the Industrial Revolution, the world began to cool. Well, it was cooling anyway because we were burning more fires and everything. And the smoke from those fires, even though it was, quote, carbon neutral because it was trees instead of coal and gas, that still put smoke in the atmosphere, which cooled the Earth. When we started the Industrial Revolution, there was very little CO2, extra CO2 in the atmosphere, which was just beginning, but there was tremendous amounts of smoke. So when you look, if you look, you know, why, when we started the Industrial Revolution, why is it cooling?
Yeah.
Then it got into like the 1920s, started going up a little bit, and World War II, there was a blip. And then it started cooling after World War II. Why would it cool after World War II? Oh, because we were reindustrializing. And again, the smoke was coming out much faster than the CO2 was accumulating until we passed the Clean Air Act, and other countries passed pollution acts in the 1970s. And that stopped the smoke from rising at an exponential rate. And then the Earth started warming at a steady pace from the 1970s onward. So aerosols play a huge role.
Also, when we brought in
But
desulfurization,
as CO2 accumulates in the atmosphere, the role that CO2 plays is going, is less and less. It's less chance of it making the Earth cool again. Robin, are you raising your hand again, or go ahead?
I was just going to say the uptick in temperatures coincided with desulfurization efforts for acid rain.
Absolutely, yeah.
So that would have unmasked
that part of the Clean Air Act, yeah.
Yeah. Okay.
And China has tremendous, coal plants in China. I saw once a picture of the coal smoke in China. It looked like the entire east coast of China was covered in clouds, and it was, but it wasn't like rain clouds. It was smoke clouds from coal plants. They have started reducing their sulfur too. Why? Because it was killing millions of people every year. Those pictures you saw in Beijing where you couldn't literally see the building across the street, but the smog was just incredible, and everyone had to wear a mask just for that. Well, they don't like that, so they started doing what we did in the 70s and started cleaning up their sulfur. So the sulfur has been dropping tremendously in China. And interestingly enough, Jim Hansen talked about this. Say, well, wait a second. Why do we see an acceleration in temperature from shipping when we didn't really see as much of an acceleration from the desulfurization of Chinese coal plants, which should have been as big a thing, let's say. And he said he thinks that the reason is that the sulfur emissions from ships happens over pristine atmosphere. There's nothing else there. So when you add sulfur, boom, you're getting the reflectivity, you're getting the increased cloud cover, and all that cools the Earth. But when you do it in China and you reduce the sulfur, there's so much other pollution there that there still is reflectivity and things like that. Yeah. So you don't have as big an effect as you think, at first blush you would, because there's so much other pollution.
Well, it's not just pristine atmosphere, but land and even cities have a lower albedo, or a higher albedo, than the ocean does. So the difference in what bounces back into space when you have sulfate aerosols over cities, the difference is smaller than when it's over the ocean, which is like a 4% albedo, if I remember correctly.
Yeah, that's a good point as well. Okay. So, Stacy, you also listened. Well, any other questions that came to your mind listening to Michael Mann's talk?
Yeah, I mean, my burning question for him is, I just want to know, does he really believe that if we get to zero emissions, net zero, whatever, that is enough, that we'll all be okay? Because, I'm an advanced layperson. But everything I've seen, it says no. I mean, the whole notion of how long it takes to affect Earth systems and what we've done, and these almost comical kind of set of circumstances, like, oh, we burned we started industrialization and it created this, and and it did that and whatever, and it's like all these sort of, it's like a Rube Goldberg machine, of what we've done. We were farming rice, and so that did this and this, it's like it's been all these sort of a comedy of errors that we've actually made it this far and this long. And what we continue, but what we're doing now, it just seems willful.
It's also at a different scale.
Yeah, right. It's
rice farming was thousands of years, little bits, just to counter the very slight cooling that we might have had, kept a very steady climate, which was good for humans. Now I think, I don't remember the exact numbers, but like half of all the emissions we've ever emitted were like the last 30 years. I mean, it was it's crazy kinds of things like that. And we're doing nothing right now to stop it. In other words, our fossil fuel emissions are at a record high. But what else do you need to know? But we talk a lot about, and by the way, solar and wind are growing at an exponential rate. They're going to overtake coal and natural gas, which is great. But unless we're lowering fossil fuel emissions at an exponential rate, it's not going to help.
As George
that's the
says,
thing that causes climate change. Solar and wind don't cause climate change, but they don't stop climate change. They're neutral. That's why we like them. But anyway, so we're not really taking the action, even by his standards. He's saying what we could do, and kind of theoretically what we could do, not what we actually will do. It's hard, when you listen to him. By the way, we're going to have Kevin Anderson on, who tells it like it is, right? And this whole idea, he thinks net zero is a total sham.
It's
just simply kicking the can down the road.
Yeah.
I'm not going to do anything now, but I'm going to promise that the guy following, not even the guy following me 2 or 3 times down this, the leader of the country, after I'm retired and probably dead, they're going to go ahead and cut the emissions to zero. There's a funny article. It was like a joke newspaper article. Sydney man promises to stop drinking by 2050, and he's like 80 years old now or something, and he says, I'm going to continue drinking just like I am until then, and by the way, I'm going to get credit for every time I didn't drink, so it's probably going to be more like 2060, but it's sort of like this thing. If you're going to stop drinking, then you stop drinking. You don't just promise to do it 20 or 30 years from now. And that's what we're doing. All the discussion about net zero is really another way of thinking about it. It's a discussion about not acting now, right? We could take dramatic action right now to cut our emissions. We could, what we've been doing is subsidizing renewables, which is a nice thing to do. We got a lot more of them now because of that. But what we haven't done is phased out fossil fuels. So that hasn't dropped. We could put a price on carbon, or even more effective, we could phase out, we could ban fossil fuels slowly over time, and then they would be immediately replaced with renewables. And then those renewables would actually act as a replacement, as opposed to adding to our energy supply, so we can just have more fun doing things with AI and driving our cars and all that kind of stuff. So there's things we could do immediately to cut our emissions as fast as possible. And that's what Kevin Anderson talks about. He said, this is not something, the way we're handling it, it's all BS, basically.
Yes.
And of course, Mother Nature doesn't really care what you say. It only cares about what you do. And it only cares about how much greenhouse gases are in the atmosphere. And now we're learning that, the climate's more sensitive to greenhouse gases than we thought. We've been cooling the atmosphere more than we thought using aerosols. This is not something that's going to end well. And that's why, I and many others think that we need these Plan B technologies that people like Michael Mann, which this is the part I don't really understand. He wants to cut emissions. I want to cut emissions as fast as he does, maybe more. But at the same time, he's against other actions that you need in case you didn't cut your emissions in time, which is pretty clear we haven't, at this point. And he's against carbon capture. I think he thinks it would slow emissions reduction. And he's also against solar radiation management for a variety of reasons. But to that, I say, if you believe that implementing carbon capture will slow emissions reduction, what you are saying is you don't believe we will take climate action seriously, which we're not now.
Yes.
So
which
would be correct. But then again, we're not taking it seriously now.
I have debated.
If we choose to take climate action seriously, that means we get serious about emission reduction and we demand them. We require them. We don't just hope for them, cross our fingers and say, pretty please, to oil companies, will you pretty please lower your emissions? That's what we're doing today. And the answer is no.
Well,
from the oil companies.
The impression that I get is that he's a climate scientist doing social science and political science as well, and not doing them well, because his overall stance is we mustn't scare the horses. If we talk about it being really bad, then everybody's just going to lose hope and do nothing, and we'll lose it that way. The impression actually that I got from James Hansen is that he's doing that a little bit too, in terms of his pessimism of when we will reach zero emissions as well, though he at least is still telling it like it is. And that's the number one thing we expect from science. And that's my big disappointment in the messaging from Michael Mann.
I think the thing that is difficult for me in all of this is the idea that there is one thing we can do. Especially as Americans, who I cannot overstate enough how much we are the problem. We have emitted more collectively as a nation and per capita than any other society on earth. Canada's creeping up because everything got set on fire recently. But we are the problem. And so we must be held to a higher standard and try and address the problem. And we don't have enough strong voices that are coming out and saying, a first step in solving the problem is admitting that you have a problem or that you are the problem. And then what are we going to do about it? What needs to happen? And it's difficult because everybody wants to point fingers. Is it you because you flew to Europe, or is it the 70 companies or whatever that they are responsible for most of the emissions or whatever? And it's like, everybody needs to, I almost wish it weren't caused by humans. I almost wish it were just happening, because then it isn't about what someone is doing. It's like, what can we do to stop it? It doesn't matter who is doing it. Every person, every company, every country should be looking at this as the problem that it is. And we must do everything we can individually and collectively to get to where we need to be so that this planet remains livable. All of the money that any of them have is not going to matter if people are suffering and dying, are pouring over borders, if there isn't enough food, if places that were temperate are now unlivable, if our oceans stop churning, people do not grasp the gravity of the situation that we are facing. They want to point fingers, and no one wants to change, and we've got to change. And so being able to convince people we're the problem and we must change, and we've got to start yesterday in making those changes. It's so important, and I just feel like it's missing because it is inconvenient. No one wants to change.
Just to amplify,
and I think Michael Mann is taking the role. He's kind of like the perfect spokesman for the media. He's knowledgeable about climate change, and he talks about it's a sense of urgency, but he's also sort of this calming thing. Yes, it's an important issue, and we must do something, but he's not like really pushing too much, and therefore that's perfect for the media, right? They can talk to him and get some more information, and yet not disrupt the apple cart too much. And so I think he's kind of perfect for that. And that's a role he's playing. Hansen, by the way, who I've known for 15 or 20 years, I've noticed the change in his attitude, which is really interesting to me, is that he used to say, this is what we have to do. And now he realizes that no one's listening to him. Like, he went to Congress in 1980 and said, we have to do this. This is what's going to happen. He was right about all of that. We didn't do anything, and we're still not doing anything. And he's going, well, I'll tell you what you need to do now. I know you're not going to do it now, but you will decide to do it later. And so we'll, I guess, just have to wait until you guys get scared enough to go do something. But when you do, this is what you got to do. And it's a little shocking to see that kind of change. He's got cynical, I guess, about about things. Robin, let's see.
Yeah,
okay. Go ahead.
I was involved in the 80s. I ran a campaign to get lead out of petrol in the UK. I was sort of the scientific medical advisor to the campaign for lead-free air. And we persuaded the government to change its position after about 2 years. So in 1983, they accepted the need for lead-free petrol. But it took another 30 years before it actually got phased out globally. Actually, it went on till 2021 in some countries like Algeria. And if you look at CFC substitutes, the CFCs got phased out, but the substitutes carried on. And it was only the Kigali Agreement of 2016 that stipulated that HFC should be phased out. I think the phase-out date is 2030. So something as simple as lead in petrol and something as simple as CFC substitutes have taken almost 40 years, both of them, to get phased out. And that is why global warming is so difficult, because, you know, CO2 combustion is entrenched in world energy systems, and it remains the most convenient method for, you know, developing nations. So I always knew it would take longer, but what is so disappointing is that we haven't even made a dent in the upward trajectory of greenhouse gas emissions. That's what's so frightening. And I mean, the scientific evidence is now indisputable. And that's what I find most concerning, I think.
Well, first of all, we haven't even gotten rid of lead out of petrol for small airplanes, by the way, even today. And now they're finally getting around to phasing it out. And the fact that we had lead in petrol and or gasoline for so long, I understand, has lowered the average IQ of the average American by a couple of IQ points. Just that one thing. And then, of course, we had it in paint. We finally got rid of it there. So yeah, we do a lot.
It's still in
the guy
pipes.
who came up. Go ahead.
It's still in pipes in a lot of places, unfortunately, and that's environmental justice.
Yeah, so the way humans work is we find something cool that works well, and we go, "Hey, great, let's go do it. I made money on this," and we go do it, and then later on, we find out that there was some problem with it. And yeah, it causes damage, but usually we fix it and then we move on. And yeah, there was that lingering damage or whatever. Climate change, though, is a different beast, because it doesn't get better when you stop doing the thing. Like when you stop emitting CO2, climate change doesn't get better. It just stops getting worse, if you're lucky. Because if you cross tipping points, then it keeps getting worse anyway. But and for example, we've past tipping points on sea level rise. So even if we stopped all our emissions today, the seas will continue to rise for centuries more, and we'll get a lot of. The last time CO2 was as high as it is today, which is 420 something parts per million, sea levels were about 75 feet higher than they are now. So that's where we're headed, even if we stopped emitting today. But we're not stopping emitting today. So there's a lot of excitement. I mean, may you live in interesting times is something that, of course, we're going to deal with.
Did you see the satellite photos of the tongue of the Thwaites Glacier from a day or two ago?
I was trying to find that. I saw a quick tweet about it, but maybe you can tell us more.
Well, I probably saw the same tweet, but it is foreboding. The ice, which has been stable in front of the Thwaites Glacier, it's really like all cracked up, and there's less of it, and that means that if that goes on, then really the Thwaites Glacier itself is going to be eroded at an increasing rate. And of course, everybody understands that this can trigger an increase in the rate of increase of sea level rise, and it can be to the point that it affects coastal property and construction in 5 to 10 years, But what I am worried about is that, especially in that area, we do not know nearly enough about the inventories of methane clathrates. And there are two things that can happen. One is, well, three things that can happen, actually. One is you're getting just the sea level rise, which is felt locally first before it, propagates through the ocean conveyor belt and ocean circulation. That changes the loading by whatever the increase in sea level is. But as the glacier itself deposits more sediment, as it's more quickly flowing out, that also changes the loading right where the glacier is, and we don't know much about the clathrates there. And finally, there's whatever affects the reduced sea ice has on local water temperatures, also potentially affecting the clathrates. So this is a huge unknown that we don't even have the data to start talking about it as something we can be confident we don't need to worry about.
Well, isn't this isn't that the type of event that Ditlevson was saying about AMOC shutdown? That might have happened, whatever, 10,000 years ago?
That was different. No, that was a huge freshwater lake that was bound by ice. And then as the glaciers retreated, that ice broke apart and all the fresh water flowed into the North Atlantic and shut down the AMOC like 14,000 years ago. A different kind of thing. But what's happening here, for the audience, just to understand what we're talking about, the Thwaites Glacier is located in Antarctica, and it's part of the area Pine Island, Thwaites, and I forgot the other one. They have sea ice that's in the sea, frozen, kind of attached to the land and holding back the glaciers, which are on land. And when the sea ice breaks apart and flows away as icebergs, that leaves like taking a cork out of a bottle, and now the glacier can flow more freely into the sea. That ice, which is on land, can raise sea level. Ice that's in the water, sea ice that's in the water, doesn't tend to raise sea level because it's already there. It's already in the water. This prediction of the breakup of the sea ice was predicted a couple of years ago, saying it would happen in the next few years, and it seems to be happening just as predicted. And this is a bad thing. Could lead to a couple of feet of sea level rise in our lifetimes, which is a crazy amount, by the way, for that short a time. Sea level has only gone up like 8 inches in the last 100 years so far because of global warming so far. And they're going to go up faster now. And 2 feet is crazy by 2050 or something. That would be an unbelievable amount. And it could be, if the AMOC shuts down and other things happen, it could be as much as 10 feet by the end of or more by the end of the century. And these are things that are not being talked about by Michael Mann or other people in general. It's just not part of the discussion. It is in the general sense, sea levels are going to go up over time, we better get ready. But these like near-term dramatic increases and things like that because of the Thwaites Glacier, for example, which is also called the Doomsday Glacier, is an issue. I also want to talk about what a clathrate is, because many people don't know that. Clathrate is or methane hydrate is methane, which is a very strong greenhouse gas, and it's frozen inside, think of it like inside an ice crystal, like a water ice crystal. And it's mostly in the deep ocean, and it's a hydrocarbon. It's methane. It's very strong, and you can burn that like it's natural gas. Think of it as frozen natural gas inside an ice crystal, deep in the ocean. It's very cold, a lot of pressure from the ocean, and it's stable. So as long as it stays that way, we're fine. There's more of that than all the fossil fuels that we burn, the other fossil fuels that we burn, but it's at the deep ocean for the most part, cold, a lot of pressure, very stable. There's also some in the Arctic Ocean where it's not as deep, but it's cold So it also stays stable. That part is warming quickly because of global warming. The sea ice is melting. Global warming is Arctic amplification. So there's a worry that the clathrates within the Arctic Sea could release. And what that would happen is you would see methane bubbling to the surface, which we do see. And as it bubbles up, it usually is captured by the ocean water before it hits the atmosphere. It's absorbed into the ocean for the most part. But if it really starts to go, then the oceans wouldn't capture it anymore. It wouldn't be able to, and it would bubble into the atmosphere. And that could cause a spike in warming just from that. I'm not as aware, by the way, Eli, about the clathrate situation in the West Antarctic ice sheet area, which seems to be what you were talking about.
Well, I was looking last night to see what we know about that particular question, and apparently not nearly enough. I found one conference abstract that was talking about the distribution on the Antarctic Peninsula. And there does likely seem to be a significant, there appear to be significant deposits there, but unusually, it doesn't seem to be at the right range of depths that they expected to, just from the physical chemistry of it. A small correction to what you said: the deposits are mainly along the continental margins. So, and this is related to the physical chemistry of clathrates. There's a range of temperatures and pressures that stabilize methane clathrates. And if you're above the depth that corresponds to those pressures and temperatures, then it's just dissolved methane in water. If you're below that level of depth, actually it is most likely, just in terms of the geology, actual gas. So if you increase the loading at the bottom, it goes into the gas phase. And there was a paper out, I think last September or maybe December, that showed that along fault lines, when the clathrates are destabilized, the gas actually flows along fault lines or other geological features if there's a pathway. And what they found was, well, there's methane bubbling up to the sea surface at lower depths from from clathrates being destabilized. But we haven't been noticing that because we haven't been looking at the different depths. We've been just looking where we expect the clathrates to be. And this is really annoying that we haven't necessarily been looking in all the right places to track the issue of whether it's getting to the sea surface interface and into the atmosphere. Another quick point.
Well, we do have satellites that can track the location of methane, so you would think it would show up if it was actually getting out of the ocean and bubbling into the atmosphere.
Well, remember, there have been anomalously high readings that people haven't been able to attribute in recent years. The other quick point is that in the polar regions, Antarctica and the Arctic, much of the time this whole region would be covered in sea ice, right? And that reduces how much of it actually makes it into the atmosphere, just because it's trapping it physically. When you have less sea ice, right, your that last little safety margin is reduced correspondingly.
Okay. Let's see what we have. Rather than getting into Albert's discussion, Stacy, I think maybe we'll invite Albert on to talk about his thing anyway and have him as a special guest. I do want to open it up to questions from the Zoom audience here. If you do have a question for myself or for Stacy or Eli, or have a comment to make, now is a good time and the way to do it is to raise your hand, and then I can unmute you, and you can also turn on your video.
The only thing I want to throw in case anyone is new, is biochar. Go read all about it, because the number of people in the audience that are just Santa Barbara permaculture people who hadn't heard of biochar, and the only reason I had ever heard of biochar is because of Albert. They were just stunned and surprised and all excited about it. And yeah, I hope biochar becomes more of a thing, because I haven't heard the downsides of it yet. So anyway, I hope he.
So let's talk about biochar just for a minute. So what biochar is when you burn biomass, which you think of as a tree or a plant, and you heat it up without oxygen. So you, in a special furnace that doesn't let air in, it turns to charcoal instead of burning like a normal thing, releasing CO2. It can't create CO2 because there is no O2 in the process. So what happens is that the tree or the biomass turns to char, which is carbon. Think of it like coal, really. And so you end up with this solid form of carbon, which is not going to be released into the atmosphere. It's not going to release its C atoms to match with the O2 atoms of the atmosphere to form CO2, which is what happens in normal combustion. So biochar is a way of turning plant matter, and remember, plant matter was made from CO2 in the atmosphere. Every living thing you see was created out of the 0.04% of the atmosphere that is CO2. Problem is, it used to be 0.03%, but now it's 0.04 because of us. And so things grow out of, and by taking CO2 out of the atmosphere, instead of dying and releasing their CO2 back, when you turn it to biochar, you put it into a solid form, going to last for hundreds, thousands of years as carbon, rather than going back into CO2 in the atmosphere. That's why biochar is this cool thing. It's the first climate solution I learned about when I first started giving talks about climate change, like 2005 or so. And I thought it was this really cool thing. I said, wow, this is going to be really exciting. Look what you can do. It's, by the way, technology that was used in the Amazon like 2,000 years ago. You can find soils today. What is it called? Soil negra or something like that. The black soil that is this very rich and great soil for growing things that was created by biochar, created like 2,000 years ago. So it's an old, very old technology. There's updates to it to make it more efficient and all this kind of stuff. So it's something that we've known how to do for a long time. It was identified early on as a climate solution, and to my disappointment, nothing much has happened with it. People have started companies. I've, as a venture capitalist, have reviewed biochar companies. They weren't very exciting. None of them have succeeded very much. At least there may be some now that are successful, but I hadn't heard, recently of any. So it's a tough business to be in, even though lots and lots of people are working on it. There's a lot of innovation, and Albert is one of the world's experts on the subject. He wrote the books about it, and so he's definitely an expert. And we'll get him on to talk about it. We've had him on before, but we'll have him on again to talk about that.
Dan, you have known about biochar for nearly 20 years, and you didn't make it a thing? Like, take them by the hand.
No, I wanted to.
Do it.
But there's a lot of problems with biochar.
What? Tell me, I don't know them yet.
First of all, you got to get the biomass to turn it in, right? And everybody wants to use biomass for this, that, or the other thing. I want to use it for this. This guy wants to use it for BECCS, which is a way of doing carbon capture. This other person wants to turn it into some biomaterial or something like it. So then you have to ask the question, how much, if we went 100% to biochar and we took all the waste biomass in the world and we turned it into biochar, what would that be? And the number I heard long ago, and I know because I talked to Albert, he thinks the number is much bigger today, but it was like 1.6 billion tons. So that, we emit 50 billion tons of CO2 every year. Maybe on the order, you could reduce it by 1 billion tons if you did 100% in on biochar. Now, Albert will tell you, no, it's much more now. Maybe it's 5 or 6 billion tons. But And there's an environmental impact. If you grow things to turn them into biochar, you're using up water or using up land. The land is darker maybe than it used to be, which might warm the earth. It's a lot. It's not like this very simple equation. Now, if you do have waste material and you do turn it into biochar, there's co-benefits. You get energy out of it. You get synthetic oils that you can use. You put it in the soil, and while it's not a nutrient, it does hold on to water better. So it helps the soil be more carbon rich and a better performing soil. There's lots of fantastic things. But from an economics point of view, it hasn't worked out too well. The companies that have tried it, and there's incredible logistics, because if you have a centralized biochar kiln, you got to truck all this biomass. And for a long time, and even today, I've seen it. People are building mobile kilns, so you bring it to where the waste is and turn it into biochar on site, for example. So it's complicated. You know, it's simple to talk about,
and sell it to every municipality. And then they have one, this is at their sewage treatment plants. This one is at the dump. This one is at, and, this one takes the organic waste. This one takes the plastics, and then it's separated into different streams. If you sell them the system, BAS, biochar as a system, or whatever, or CAS, kilns as a system.
It's hard to do, by the way.
But sell it into municipalities, and then everywhere has it, and then you're not trucking it all over the place or taking the kilns, because if you can do it in the Amazon thousands of years ago, you can freaking do it in any town or city now. But they don't know how.
No, people know how. I mean, biochar is a well-known.
Why aren't they doing it?
Well, a lot of people don't know about it. Again, there's limits to the impact it can have, even if you did it at full scale. That's one point I wanted to make. It's a good thing. It's also, and this is something I only learned about recently, if you take this tree, which let's say it's a ton, the tree weighs a ton, and you turn it into biochar, you don't get that whole ton into biochar. You only get a small percentage into biochar. The rest is other stuff or something that maybe recycles it back into the biosphere. Again, Albert knows a lot more about that than I do. But so it's not like, it's not this panacea. It's a good thing, and it has positive, unlike other climate solutions which have negative side effects. This one tends to have positive side effects, like better soil, and other things like that. Again, energy generates energy. It's burning the wood in a way that doesn't release CO2. You can think of it that way. But to my disappointment, even though I heard about it 20 years ago, nothing much has happened. I mean, I'm sure there's a lot that's happened, and Albert would know everything that's happened, but it's not positioned as a primary climate solution. I would call it a secondary climate solution, and a good thing, and we should do more of it. A lot of cool companies working on better kilns, mobile kilns, more efficient kilns, how to handle those logistics. Again, sourcing the material is one of the key problems. You can do it on your own in your farm or something, easily.
But even if it's the Waldorf salad,
that's a no-brainer, but that's not going to make a huge.
Even if it's the Waldorf salad of on the buffet of climate solutions, we should use it. It should be there. It should be an option, and we need all hands on deck. We need all solutions. Like, none need to steal from the others. Like, just, how many things can we greenlight and get going?
Let's go to Robin again.
Yeah, I agree about biochar. I knew a chap who ran a company called Carbon Gold, and he's told me that when his ancestors first crossed the American prairies, the carbon content of the soil was 100 grams per kilogram, and now it's been depleted to about 5. So one of the best ways of restoring the fertility of the soil is to put carbon back into it using biochar. And then, of course, you wouldn't need to use so many nitrogen fertilizers,
Mhm.
and that would also benefit climate. So I agree with the lady here.
No, it's a good thing. I want to see it go, but people haven't figured out economically.
Yeah, it's difficult to scale up. It's got to be done at scale to have a big effect. But
Exactly.
it's an obvious thing to do.
I agree. Yeah. Okay. So we did cover Albert a little bit.
A little. Oh gosh, that was just
we'll
the
cover it more though.
tip of
I'd like to
stuff.
cover it with Albert because that would be so much
Yeah.
more informative for everybody. So we'll
Yep.
do that. And we have Eric here raising his hand. So keep clicking on Ask Them. There we go. And
I'm trying to turn on the video. I can't seem to.
let
Okay.
me. Yeah, I don't know why I can't do that. So I just changed
I'll
it
just
so
ask
you
the
can.
question.
So now you should be able to do
it
it.
occurs to me that maybe there are, I guess this is a good Albert question on, I can ask in a future week, on, are there big pools of unused biomass? Like I'm imagining huge algae blooms where you could put a kiln on a barge or a set of kilns on a barge and consume, biomass that no one else wants.
He actually talked about that a little bit. I can't remember exactly where, somewhere in Mexico, they're having enormous amounts of seaweed wash up on the beach, and it is taking away from the tourism, and it's what to do. And so they've been doing that. The other, he was just here, he was in Sacramento for the, I don't know, national, worldwide, whatever, biochar conference. And he and the guy who had a biochar company, they came down, I think, to Chabot, Dan, in Oakland, to biochar up some of the eucalyptus, because Oakland has, well, and most of the Bay Area has way too many eucalyptus trees, which are a fire hazard. That's how we lost so much housing or so many homes on the Oakland Hills. And so they've been trying to thin and get rid of the eucalyptus trees. So we're more than willing to take them down and biochar them. And they did a bit of that last week.
But still not at global scale. That's
no. Gosh, no.
good thing to
That's what I was
do.
thinking. Maybe some algae blooms are big enough to be like globally interesting. I'm just wondering.
But there's other things you can do with algae. If you can grow plankton and algae in the middle of the ocean and get it to sink to the bottom of the deep ocean, then it's out of the carbon cycle for 1,000 years, and that's probably an easier way to handle that. So,
Dr. Brian's here to tell us what else we can do with algae, like fuel and something.
I have one more point to make, but you guys can go.
Go ahead, Eric.
Oh, I just wanted to. I put into the chat. There's a really super good episode of Words to Win by Anat Shankar Osorio on the topic of Costa Rica and their campaign, no puncture campaign, to keep any oil companies from doing any extraction or even searching in all of Costa Rica. Admittedly, a small country, but it's a very moving and interesting podcast. Words to Win by. I recommend it.
Very good. Very good. So, Dr. Brian, you're here. I don't know if you have something to say. We were talking about biochar just now and algae, and I just saw you join. So you might have joined because you were listening, or maybe you just popped in and you don't know what's going on. So, but you're welcome to comment if you'd like to. I'm going to turn off the security here so everyone can unmute themselves. Okay, well, Dr. Brian's not saying anything. I think it's been an hour and a half. I think we've had a good discussion. We heard from Stacy about her trip to hear Michael Mann, and we had a good discussion about that. We talked about a lot of other things, including the Thwaites Glacier and biochar and algae, and we covered a lot of different subjects. So I hope it was an informative session. I do want to say, we do have Brian, but before we get to Brian, I do want to say that I want to remind everybody that while this is an open discussion room, the next 3 climate chats will be special interviews starting on Sunday, March 3rd, with David Fenton. David started the largest PR company for social causes and worked with Nelson Mandela and Yoko Ono and even with Castro in a very funny way once, and has retired from that, sold his company, retired to focus on climate communications. He's been a guest several times before. Everyone's always been really excited when he's on, so you don't want to miss that. That's next Sunday. The following Sunday, March 10th, we have Dr. Renee Van Westen, who wrote a paper recently on AMOC collapse, both on the probability of AMOC collapse and the impacts of AMOC collapse. Super important subject that we've been covering here quite a bit. So that'll be fantastic to get into the details with her on her paper. The following Sunday, March 17th, we have Professor Doug McMartin from Cornell University, who's a researcher on sunlight reflection methods, solar radiation management, solar geoengineering, whatever. It's unfortunately an understudied area of academia. And we've had him on before. Very interesting discussion. That was on Clubhouse. And unfortunately, that was when Clubhouse was making the transition. So it was really, I couldn't recover the audio recording from that because they were screwing things up back then. So we're going to have them on YouTube anyway, which is going to get a lot more coverage and a lot more people will have access to that. And then also on top of all of that, even though we don't have the date specific yet, Kevin Anderson, climate scientist Kevin Anderson, one of our most popular guests ever, and one of certainly the most interesting, detailed 3-hour interview that we did, is agreed to come on again on YouTube this time. And although we haven't set the date, it won't be on a Sunday morning. This will be a special edition, probably a weekday morning, the Pacific time, and evening in the UK where he lives. And we'll cover some of the subjects we covered before, but he tells it like it is. In fact, so much so that, I heard him 10 years ago and he freaked me out, got me working harder. But then I forgot, how troubling it is to hear what he's saying the first time. And got feedback from the interview that people were freaked out. So I put a warning on the YouTube video, like, don't listen to this if you're not really ready.
Well, I think I want to say we had him in like almost our evening, because I can see myself kind of in the kitchen and I remember I should grab a drink. I don't know.
Well, no, you definitely want to grab a drink before you listen to Kevin.
Yeah.
But he's been very active and increasing his public profile. He's been doing a lot more, outreach. He has his own videos that he does and everything. It's really great. And he really tells it like it is. He talks about the BS of net zero, how the governments really aren't doing anything, how the rich don't want to change their lifestyle. I have so many quotes from our interview with him that are really shocking. Things like, I can also remember them, there are no non-radical futures. Either the future is radically different than the present because we make the radical changes necessary to fight climate change, or we decide to muddle on for a few more years with trying to maintain the status quo, and then climate change will cause radical changes to us so that we will have a radical future either way. So it's up to us to choose which radical future we want. But so far, we're choosing the latter, unfortunately. So anyway, so that's Kevin Anderson. I'll certainly announce it on Twitter. You can follow me at DanMiller999 on X or Twitter, and I'll post it on LinkedIn as well. And obviously, if you subscribe to the YouTube channel, you'll see it pop up there. But that will be a special interview, probably sometime in the next month. We'll do that. He wrote to me today saying that he'll get back to me soon with when he can do that. Let's see. It says Eric has his hand raised first. So Eric, go ahead.
No, I asked my question already. Thanks.
Oh, you did already. Okay, we've got to lower your hand here. Okay, Dr. Brian.
Yeah, when it comes to biochar and macroalgae seaweed, it's once if by land, twice if by sea. We've been working on macroalgae for the past decade with something called marine permaculture, which restores the supply of deep nutrients to seaweed so that it can continue to grow. Algae is down around 30 or 40% in the Pacific, in the subtropics and the tropics. But even in temperate latitudes like Northern California, they've lost over 90% of the Nereocystis giant kelp forest due to the water being too warm and the nutrient levels being too low. So that has been a bistable shift. It's now taken over as urchin barrens. And it's a real challenge. We're going to have to get rid of 99% of the sea urchins to get back to some kind of state where the seaweed can start growing well again. We've seen these urchin barrens as far south as New Zealand and Tasmania. So it's across the Pacific Ocean we've seen these problems, and it's going to be a global problem in the future. So these are sadly degraded, stable states where, you know, it's a tipping point that's already happened, and it's affecting thousands of square kilometers of kelp forest. I think that 100 years ago, there were 3,000 square kilometers more of kelp forest off of just the United States and Australia alone, and that's 2 countries out of 200 where we've documented it. So it's a serious problem, and just getting back to pre-industrial levels will require thousands of square kilometers of what I would call afforestation or regeneration of the kelp forest that existed pre-industrially.
Okay. Well, with that, we'll end on that note, and want to thank everyone for coming. Stacy, thank you for your report, and I think it was a really interesting discussion. Don't miss Climate Chat in the next upcoming weeks with all the interviews I just mentioned coming up. Please subscribe, smash the like button, follow us on Twitter and LinkedIn as well. I don't know what my LinkedIn, I know I'm just Daniel Miller, I think, on LinkedIn somehow. I don't have any fancy numbers afterwards. And looking forward to next week. Thanks everyone for coming, and thanks for joining. Take care, everyone.